This video is for my pre-calculus students. We're going to be doing lesson 40, page 206, talking about the differential. Differential is very similar to a derivative, but it's going to add some things to it. The beginning of the lesson talks about two brilliant scientists, mathematicians, Isaac Newton, who you're familiar with probably, and a German mathematician named Gottfried Leibniz. They both invented calculus at the same time. They use the word invented because it's such an incredible step in math and what they came up with. And just for reference, when Newton came up with the derivative of y, he used y with a dot over it. That eventually became y prime. Leibniz used the change in y over the change in x, dy over dx, which we'll be focusing on in this lesson. The book uses both y prime and dy over dx and f prime and other notations for a derivative. We focus on Leibniz's because it helps to, in later, more complicated problems, it becomes far more useful, and we'll even see part of that today in the example they give us. On page 206 at the bottom, they give us three expressions. They give us y equals 5x to the fourth, the function of t, f of t equals 3 sine t, and g of u equals ln u. And we would go find the derivative of all of these. Now, in all of these, we're going to use Leibniz's notation. He said the change in y over the change in x. We know that the derivative is going to be 4 times 5, that's just 20, and x cubed. If we move to the next one, how do we write that in this form? Well, in this form, it would be the change in f over the change in t, df over dt. By the way, this variable here must be the same as the variable out there. In this third one, it would be dg over du. So let's see what each of these equals. We already found the derivative of the first one, 20x cubed. The derivative of the second one, well, it's the function that's really being performed on t is taking the sine of it. So it's this constant times the derivative. So it's 3 times the derivative of sine t, which is just simply cosine t. Over here, the derivative of natural logarithm of u is 1 over u, stuff we learned last week. Now, that's the derivative. The differential is getting this numerator all by itself. In other words, I want to get rid of this dx. Well, it's just simple algebra. I multiply both sides of the equation, and I get the dx over there. I get dy equals 20x cubed dx. You know, what's the big deal there? Well, as I said, in later problems, this dx will become very significant and have its own numerical value and will help us find some higher, more complicated problems. In this second one, I want to get the df by itself, so I'm just going to multiply both sides of the equation called by dt, and I get that df equals 3 cosine t dt. They don't put parentheses around this, but you could. That is not t times dt, that is the cosine of t times dt. Last one, I'm going to multiply both sides by du. They will not give you this as du over u. They always keep this differential part separate, off to the side. In fact, this is dy is 20x cubed dx, and this dx tells you kind of the what variable it is. that's being used in this problem. You go, well, it's simple. It was an x. It was a t. It was a u. Yes, but sometimes they give you problems that have multiple variables in them, as they do in this example at the top of page 207. It says, if y equals this, find dy. If you were going to find the derivative, okay, you can't say dy over dx because it's going to change. Here we've got x, here we've got u, here we've got not e, but t as our variable. So dy is going to be the derivative of 3x to the negative 2. Negative 2 times 3 is negative 6x. Subtract 1 from 2, I get negative 3. But notice they don't have dy over dx. They want that dx out here. With respect to x is what they will sometimes say. Plus, what's the derivative of 2 cosine u? Well, it's 2. I don't know if we've covered this, but the derivative of cosine is negative sine u, and then you have a du after it. Negative 5, what is the derivative of e to the t? Well, the derivative of e to the t is e to the t, and because it's a differential, you must have that dt behind it. The only thing that's going to change is this negative with the sign is going to make this negative 2 sine u du. That's pretty much it for now. Finding the differential is just putting that denominator back up on the other side. So the dx here comes here. The du here goes there. The dt here goes there. That's lesson 40. Let me know if you have problems, if you have questions. God bless you all. Hope to see you real soon.